Let's have a review on what we have discussed yet about the maximum operational zero sequence voltage. In the previous session, we have discussed that for defining the maximum operational zero sequence voltage, we should consider a type of our system. If our system is in radial type, then we apply 3 volts. Then uh, if our system is not in radial type, it's in ring or in a mesh, we first find the zero sequence voltage. I mean this one, the zero sequence voltage we find according to the calculation or whatever. Then if this zero sequence voltage is lower or lesser than 2.5 volts, then again we apply as a maximum zero sequence voltage, operational zero sequence voltage in the system, we apply 3 volts. And whenever our system is in ring or in a mesh type, and we find the zero sequence voltage, the V0, we find it from the relay from DXZ or by the calculation. If it is greater than 2.5, then we apply this amount of zero sequence voltage, that is zero sequence voltage multiplied by whatever it is, greater than 2.5, any, it can be 2.6, then we multiply that value of zero sequence voltage by 1.2. It means we apply 120% of zero sequence voltage as a maximum zero sequence operational value. Instead of applying 3 volts, we apply zero sequence multiplied by 1.2. On discussion about how to find the zero sequence voltage from the Vin, we already discussed that there is a method for finding zero sequence voltage. One is reading from the relay from the device itself, another is reading online from the DXZ5 or from DXZ softwares. Then another method is having a Vin or the neutral voltage. If we have a neutral voltage taken from the broken delta, like having a broken delta winding, if you have, then we know that the voltage on each of these phases is the rated voltage divided by 3, because the overall is 3, and Vn is 3 times of V rated divided by 3. And also the difference, the matching ratio of Vn and V0, it is matching ratio is 3V0 divided by Vn, and that is equal to 3. It is itself V rated on the star winding of the transformer connected to the phases. This is a star winding Vt divided by root 3. That is the V0. We previously we discussed that V0 here becomes the equal to the voltage of each of the phases, and voltage of each phase is V rated of that transformer secondary winding that we call is as star, VR star, divided by root 3. And overall Vn, we calculated that Vn is 3 VR in delta. It means whatever the rated voltage in the secondary side of the delta connected transformer is, open delta transformer is, divide by 3. Now let's have more details on this V-rated values of star winding and the broken delta winding. Sorry, it's called broken delta. It's not open delta. Open delta is another type of the winding. This value of V-rated in star type of the winding, this value, whatever it is, we replace it. We substitute the value, and also whatever the voltage on each winding of this transformer is, in a broken delta winding, whatever the voltage V-rated secondary side is, that we replace here in VR delta. And we find the matching ratio, and also we find the V0 from here. And according to the V0, we find that what should be the maximum operational zero sequence voltage in our system. For example, here sometimes these voltages are not equal. V rated on the broken delta side, it is not equal to V rated on the star connected for the phases. Just we replace in our system the values. For example, here is an example that Siemens has explained in its relay manual, that V rated in the phase to ground voltage, it is 100, and broken delta winding, it is 500 volts. But we cannot apply this 500 volts, and it is we try to use one voltage divider. According to that voltage divider, we apply 200 volts onto the relay. So first we find the matching ratio, then the matching ratio according to the formula V phase and Vn, this 3 V0 Vn, and V rated here we find we replace 100 volts divide by root 3, but here in broken delta it is 200 volts applied in the relay, and here we find this is our matching ratio. This matching ratio is founded. Now we find this V0. V0 is equal to, according to the same formula, just V0 Vn, the value of the Vn, and the matching ratio that here in this example it's 0.866 divided by 3, and here we replace Vn as a 200, then this matching ratio divided by 3. This one becomes the overall V0 that we found. This V0 is definitely greater than 2.5, so we multiply this V0 to 1.2, and that is the maximum operational V0 sequence. All of this what we have discussed is only right when we have a broken delta for neutral voltage and star connected winding for the phases voltages. For example, if we have this type of the winding, the phases windings are connected in the star connection, and for the neutral voltage, we only have two voltages the voltage of two phases only. Then it is not divided by 3 or whatever that we have discussed before. Here in this example, we have in star connection, the secondary is not in delta connection to be a broken delta, and only two phases are taken. So it is V rated divide by root 3, that is the voltage of each of this winding, and overall Vn which we calculate and which we achieve here. This Vn is only the winding of two phases, so it is divided by 2. This condition is the relation of 3V0 divided by Vn. It is then instead of Vn we replace this amount of the value in this formula. In this example, this is the phases winding are same as we have discussed before. And whenever both of these two windings, windings for the phases and winding for the neutral voltage is totally changed, so another relation should be achieved. Because in this type of the winding, then we don't have V0 equal to, we don't have V0 is equal to VA. That is, this relation is wrong. So 3V0 divided by Vn, that value becomes wrong, that relation is wrong. And also for the neutral voltage, then we don't have any type of broken delta, winding, or star connected two phases taken out. In these type of connections, first we should find the V0, whatever this V0 is supplied to the phases. Then that relation comes into the picture. We should find V of the phases divided by Vn. Again, in this type of the example, this is true according to broken delta, but here the connection is different. In this type of the connection, we even don't have Vn to calculate V0 from that Vn. And for the next example too, same for this type of the example, which we don't have Vn.